Welcome to the podcast called Introduction to Solving Linear Inequalities. Before we begin actually solving our linear inequalities, I want to remind you a little bit about solving linear inequalities. When you solve linear inequalities, the steps that you use are basically the same steps as when you solve an equation. If I had the equation negative 4x is equal to 20, I would just divide both sides by negative 4 and get x is equal to negative 5. Okay? Now, it's a little bit different with an inequality. In the inequality, negative 4x is greater than or equal to 20, I still do the step divide both sides by negative 4. However, with inequalities, anytime you multiply or divide both sides by a negative, now it's only multiplying and dividing, but if you multiply or divide both sides by a negative, that switches the direction of the inequality. As soon as I put down here divide by negative 4, this inequality stops going this way and starts going the opposite way. Right as soon as I divide. Don't wait till you come down here. As soon as you divide by negative 4, switch the inequality. Now you have to do it. Not something that's already there, it's something you did. And then you get x is less than or equal to negative 5. Now contrast this with this second problem. In the second problem, it says to solve 8x over negative 4 is less than 15 over negative 3. Here, the negative 4 and the negative 3 are already in the problem. If I reduce this, negative 2x is less than negative 5, it's true that I got negatives, but I did not divide both sides by a negative. The negatives were already in the problem. All I did was simplify the fractions, so the inequality does not reverse. It reverses when you multiply or divide both sides by a negative. Okay, let's go into the problems. The first problem says solve 5 minus 3x is less than or equal to negative 4. And as I said, the steps are the same as when you're solving an equation. So the first step would be to get rid of fractions if we had any. The second step would be to get x out of the grouping symbol if we had a grouping symbol. Well, we don't have either one of those. So the third thing says get your x terms on one side and your non-x terms on the other. Well, I have a non-x term here, 5, so I'll move it to the other side, and I get negative 3x is less than or equal to negative 9. And then to finish solving, I divide both sides by negative 3. It's something I'm doing. I'm dividing both sides by a negative, so as soon as I do that, I switch the inequality. Now, when you bring it down, don't switch the inequality again. If you switch an inequality twice, then you didn't switch it at all. Here the negative 3's cancel, and I have x is greater than or equal to 3. Now, when you're doing these problems, give your answers in all three forms. That is the inequality form. Here is the graphical form. The critical number is 3. So we graph the 3. X is bigger than the 3, so it would be to the right of the 3. X can also be equal to 3, so we would use a square bracket to indicate that x might be 3 or it might be a number bigger than 3. And then the interval notation is just the graph without the number line. So you start with that bracket. That bracket is at 3, so you put a 3 there. It goes all the way to the right, never stopping, so it goes to infinity. And anytime infinity is part of the answer, it always gets a curved bracket. So there are your three forms: inequality form, graphical form, interval form. Let's take a look at the second example now. In the second example, we notice that we have an inequality with fractions. There are three terms. These first two terms, the 2x minus 3 over 6 and the 1, are separated by the plus sign. The 1 and the 2x minus 1 over 12 are separated by the inequality sign. So that's a total of three terms, common denominator 12. So the next step I'm going to do is multiply every term by the common denominator. So that's 12 times 2x minus 3 over 6 plus 12 times 1 is greater than 12 times 2x minus 1 over 12. A lot of students want to skip and not write this step. But this step is crucial. To write it clearly and write it neatly could keep you from making some serious mistakes in your work. Okay, the 6 cancels with the 12, so that gets rid of one denominator. The 12 cancels with the 12, and that's get rid of our another denominator. We now have no denominators. So the result is 2 times 2x minus 3 plus 12 is greater than 2x minus 1. The next step is get x out of the grouping symbol, so we write 4x minus 6 plus 12 is greater than 2x minus 1. While I'm thinking about it, let me remind you of something. When you're getting rid of denominators, don't just multiply the terms with denominators by 12. This term had no denominator, but it still got multiplied by 12. You're multiplying every term by 12, whether it has a denominator or not. Okay, we've gotten rid of our fractions. We've gotten x out of the grouping symbol. Now we want to get all our x terms to the same side, so I'll subtract 2x from both sides. And we want to get all our non-x terms to the other side, so I'll add 6 to both sides, and I'll subtract 12 from both sides. And now that on this side leaves 2x, and on this side it will leave 2x minus 2x zeros each other out, so this will be negative 1 plus 6, which is 5, minus 12 is negative 7. Now, even though there's a negative there, I don't reverse the inequality because I'm not dividing both sides by a negative. I'm dividing both sides by a positive. So the 2's cancel, leaving x is greater than negative 3.5. So if I want to put this in the graphical form, I locate negative 1, negative 2, negative 3, negative 4. And negative 3.5 is right between them, so above that I write negative 3.5. So anybody looking at my work will know what I'm trying to graph. I arrow to the right because x is bigger and it's greater, so I use a curved bracket. In interval notation, that's curved bracket, negative 3.5 to infinity. And that completes the podcast.